Welcome back. This is number 3 right here. Now, this might look familiar to some of you. It looks like it's going to be our arctangent. So this is almost our arctangent. However, if I want to integrate this one, arctangent unfortunately will fail because we have that 3/2 power. So we're going to use our trig substitution. So before I do that though, I'm going to rewrite this. That 1/2 power means I have a square root. So I'm going to write this as the square root of x squared plus 1 cubed. Like so. Make the arctangent easier because remember, I need to think about everything I need to replace here. I need to replace the x, the dx, and the square root of x squared plus 1. So, because arctangent will fail in this one, I'm going to use my trig substitution. And in this case, because it's arctangent, we're going to use, it looks like arctangent, we're going to use our tangent of the angle. Tangent of theta equals, remember it's going to be u over a, so u in this case is x, a is 1, so it's just x over 1, give me x equals the tangent of theta. Now, that allows me to replace the dx by taking the derivative, which gives us just the secant squared of theta d theta. Now that replaces the dx. We still need to replace the square root of x squared plus 1 right here. And to do this, again, like before, we're going to use our right triangles. There's theta, there's our angle, there's our right angle. Tangent, remember, is the opposite over the adjacent, and of course using Pythagorean theorem, x squared plus 1. And remember, this is what I want to replace, so I got to think which trig function has the will be the easiest way to replace it. And it looks like cosine, because remember, cosine of theta is 1 over the square root of x squared plus 1. And so if I flip it, I get the secant of theta equal to the square root of x squared plus 1. Very quick and easy. I don't want to use like sine because I got x over that, and it makes it slightly more complicated for us. Not that we couldn't solve it, just going to be a little bit more challenging for us. At this point, I'm going to replace everything now. My original was dx over the square root of x squared plus 1 quantity cubed. The dx, we just said we're going to replace that with secant squared of theta d theta, and the bottom, when we replace it, becomes the secant, be careful, cubed of theta. And if we simplify this, we get 1 over the secant of theta d theta, which is, don't put that on top, don't say secant negative 1, that's cosine of theta d theta, which equals which equals positive sine of theta plus c1. Now there's our answer, but don't forget we want this in terms of x, and that's just giving me the opposite, which is x, over the hypotenuse, which is the square root of x squared plus 1 plus c1. And there's our antiderivative. All right, our last one, slightly more challenging here, so let's take a look here. Number 4. Okay, on our last one here today. Number 4. Now this one's going to have a domain on it. So let's go from root 3 to 2 of the square root of x squared minus 3 over x dx. Now again, my u substitution doesn't work because my du, my dx would be du over 2x. It would not cancel with that x. They'd be multiplied together, so u substitution fails. This looks like it's going to be arc secant, and the reason for that is because we got x squared minus 3. So this is going to be our trig integral, so we're going to use the secant of theta in this case. So when I rewrite this one, I'm going to say my u is x, a is the square root of 3, and we know that the secant of theta is going to be x over the square root of 3. Give me x equals root 3 secant theta. Now, I have x, I got to replace x, so let's look at everything we have to replace. we got to replace x, we got to replace the dx, and we got to replace that x squared minus 3. We got to replace everything here. So I got the x. To get the dx, take the derivative, square root of 3, secant theta, tangent theta, d theta. So there's our dx. And now we have to replace the x squared minus 3. So to replace the x squared minus 3, use your right triangles. There's theta. Secant, be careful, secant is hypotenuse over the adjacent. And that's going to give me this length over here as opposite side x squared minus 3. This is what I want. So which trig function will nicely give us, with the fewest number of variables, will give us the opposite side, and in this case we're going to use tangent of theta. The tangent of theta is going to be the square root of x squared minus 3 over root 3. So we can say that the square root of x squared minus 3 is root 3 tangent of theta. Remember, I want to use an easy one. That's the easiest, okay? I don't want to use like a sign where I'm going to have this, all of this over x. Take a look. If I do that, I'm just going to wind up with what I started. It just looks a little bit more complicated for us. Once I have all of this, I can now replace. Okay, I can now replace. Notice I'm not from square root of 3 to 2. I'll rewrite out the problem. This now becomes, now notice I'm not going to replace my domain just yet. We said the top here just becomes root 3 tangent of theta. The bottom becomes square root of 3 secant theta tan theta. Over here we get the square root of 3. Whoops, sorry. The bottom, sorry, is x, is just the square root of 3 secant theta. Sorry about that. The bottom is just that. There we go. The dx is the square root of 3 secant theta tan theta d theta. Be careful. As you can see, it's kind of easy to make a mistake there. Now our secants cancel. So do these square roots of 3's, and I write out what's left. Root 3 tangent squared theta d theta. Now I can't integrate tangent squared theta directly, but remember, the tangent squared of theta is one of our Pythagoreans, is just secant squared of theta minus 1. And that I can integrate. So I get the square root of 3. We get secant squared of theta minus 1 d theta. And I'm going to integrate this before I change my domain. I get the square root of 3 tangent theta minus root 3 theta. And now I'm going to change my domain here. Now be very careful. To change our domain, we have to go way up here, where we said that the secant of theta is x over square root of 3. So if x is the square root of 3, we're going to get this. The secant of theta is root 3 over root 3, which is 1. And what's that going to give us for theta? Well, where is secant equal to 1? Same thing for cosine is 1 at 0. So this is going to go from 0. If I let x be 2, we get the secant of theta equals 2 over root 3, which is where remember, this is where cosine of theta is root 3 over 2, and that is our pi over 6. So we'll go from pi over 6. And now when we apply the FTC, we get f of pi over 6 minus f of 0, plugging it all in. Oh, hello, focus, focus. At the very end, then it becomes unfocused, right? That's the way it works. And there we go. Give a second here. And if I plug it in, we get the square root of 3. The tangent of pi over 6 is just 1 over the square root of 3 minus, this becomes the square root of 3 times, plug in theta, pi over 6, and plug in 0. Well, tangent of theta is 0, 0, minus 0. So we get 1 minus pi root 3 over 6. And there's your final answer here. So take a look at these. These are pretty hard to do. Probably the hard thing we're going to do all year long. So you'll be begging for these when we get to series and sequences. Okay? I'll see you later. Bye-bye.